Hello, can you hear me? Please respond. My voice is clear to you. We will start in 5 minutes. Please wait. People are joining. Hello, my voice is clear. Okay, thank you for your response. Let's wait 1 minute more, then we will start. So today we will discuss second assignment. 1 minute. Okay, so let's start. This is second assignment. Here we will discuss 40 question. So first, let's see what is the space lattice. In last class, we have discussed one question on this there. So space lattice, you know, neighborhood should be same. So let's read the definition. A space lattice is defined as an infinity array of the points in three dimension, not in one or two. Three dimension, one dimension, two dimension also maybe, but this is three dimension in which every point has a surrounding identical to that every other point in the array. So this is important point. Array example for easy of representation on paper. Consider a two dimension. Let's say this is two dimension array in figure by representing translating of two vector A and B. Vector A and B on the plane the paper we can generate the square array. The magnitude of A and B are equal can be taken by 1 unity or the angle between them is 90. Here we are called the fundamental translation vectors that generate the square array. This is the A vector, this is B vector. If we translate this vector B, let's say translate this direction and translate in this direction, we can generate the square. This is also A, this is also B. Okay. Then next, unit cell and primitive lattice. So what is the difference between these two? Please remember. So primitive cells effectively only one lattice point should be only one lattice point within the lattice within the crystals. Unit cell can have any number of lattice points, more than one. Choice of the for both standard choice for the primitive unit cells. This is with lattice point only at the corner. This is the standard choice for the primitive unit cells. And this is the special name Wigner site cells in real space, Boolean zone in reciprocal space. So what is the more important for this? Only one point. Standard choice is like that. Atom should be at corners. And contribution of all these four should be one. Clear? Clear to all? So let's move. Crystal, how we can make the crystal? Crystal is combination of lattice and basis. Lattice and basis. So what is lattice? This is the periodic geometrical structure set of points. This is hypothetical. And what is the basis? Basis crystal an atom or the group of the element atoms. Like CFCC lattice plus Cu atom or Fe atom. These are the example. We have FCC lattice, array of points, hypothetical, and basis could be Cu atom or Fe atom or Ag atom. Then this is the example of crystals of the FCC basis. So let's discuss unit cells. One minute. Give me 1 minute. Okay. So let's discuss the examples. Unit cell 1, 2, 3, 4, 5, 6 are the we are mark the area 2D for the unit cells. Please verify these are the unit cells or not. Which one has the unit cell 1, 2, 3, 4, and which one is not, and which one is the primitive unit cells. For primitive unit cell, only one lattice point should be inside. Contribution should be 1 of the space lattice space lattice points. Please verify by yourself. So this is 1, let's say. This is contribution of the all the 4 atoms will be 1. This is 1/4 into 4 corner 1. So this is primitive unit cell, also the unit cells. Like that you have to verify. Okay, do yourself this work. This is second also, and check this. Why third is also, but not the primitive unit cell. Why this is has a more than one point, lattice point, and fourth also like that, and fifth also, but also not a unit cell that can't generate the whole lattice space. Six but has. So we also construct Wigner side cells for this as a rule. First we have to choose the origin lattice point, join it to its first neighbors, then draw the perpendicular bisector of the core connectors and join to its second neighbor also and draw the perpendicular bisect. And this is the smallest volume. Okay, so see, let's say this is the center and we have first and second neighborhoods. Red one likes, let me mark. This is first neighbors. First neighbor means smallest distance, and draw the perpendicular bisector like that. I am drawing. Also we have to check for second neighbors. Also draw. So this is the volume we get the smallest, and this is called WS. Ignatius lattice. Okay, so let's discuss the first question of this session. Most brevis lattice are in the type of. Yes, please. If you have idea or near most brevis lattice are the type primitive unit cells, body center unit cells, end center unit cell, face center unit cell. Most brevis lattice. So let me show you answer. Answer is first primitive unit cell. Out of 14 naturally occurring brevis lattice, 7 are primitive. Remaining 7 consist of 3 body centered, 2 face centered, and 2 end centered. Okay, so this is the information. Please learn. Shape of the primitive units, primitive cells of abscissa lattice is abscissa lattice. Shape of the primitive cells of abscissa lattice is cubic, parallelepiped, monoclinic, orthorhombic. Yes, please answer. So answer is parallel piped, and you can see if we connect first neighbors and we construct the primitive cells like centered one, and this is the face atoms, and this is sorry top one, this is back one, this is front one. If we join these, construct the volume, we will get parallelepiped. Following reason explains the absence of the end center cubic lattice among the brevis lattice. It violates the symmetry requirement of the cubic lattice. It can be represented by the simple cubic lattice. It is not a valid space lattice. It can be represented by the simple tetragonal lattice. Absence of end center cubic lattice. So first it is violate the symmetry requirement, and it can be represented by simple tetragonal lattice. You can see in the picture is taken from the lecture, and center cubic is we can simple tetragonal. If we construct, we will get the simple tetragonal cubic cell. So let me show you. A unit cell has A equal to 5, B equal to 8 angstrom, C equal to 3 angstrom, and alpha is 90, beta is 65, gamma is 54. The space lattice for this unit cell is orthorhombic, monoclinic, triclinic, rhombohedral. Which type? You know, here is A not equal to B not equal to C. Also, alpha not equal to beta not equal to gamma. Which system has this type of relation? Yes, please answer. So answer is triclinic. We have already discussed in the last class this type of question. Okay. So next question. Which of the following is true for a face-centered cubic structure? FCC means face-centered cubic. Let me draw. Then this is at the corners. Also has on face. This is back for back and this is for front. Like that, atoms are distributed. So FCC, please find the answer now. Atoms are at corners. Atoms at corner and center of the cube. Atoms are at corners and face centered. Atoms are the edge centered only. Please see the picture and choose your option. Red one are at the corners and blue one are at the face, but center in the face. C is correct answer or yes or no? C. Atoms at corners, you can see red one and blue one at the face center. Okay, so C is the correct answer. You can see if atoms are at the corners only, this is for the simple cubic. Atoms are corner and center of the cube. This is BCC. Atoms are edge center. This doesn't represent any standard cubic system. Okay, so number of the primitive lattice in BCC is number of the primitive lattices in BCC lattice is body centered cubic. Let me draw body center. Atoms are at corners, also within the body center of the cube. Now please find the number of the atoms which is contribute to this lattice. At the edge, sharing is 1 by 8. And how many is 1, 2, 3, 4, 5, 6, 7, 8? And plus 1 is at the center. Now this is 2. Check the answer. Okay. Clear to you? Which of the following is correct relation between the lattice parameter and of an orthorhombic crystal system? Please check 1 minute. So answer is B. Let's see. In cubic, length are equal and angle also 90 are equal. In tetragonal, A equal B but not equal C. Alpha, beta, gamma are 90. Okay. In orthorhombic, alpha, beta, gamma are 90s. These three are the system which has alpha, beta, gamma are 90. Cubic, tetragonal, orthorhombic. Other doesn't have equal to the 90. Triclinic, A equal B equal C but not angles are not equal. Okay. These are the relation, please remember. Which of the following crystal system contain only one type of Brevis lattice? Primitive. Tetragonal, orthorhombic, hexagonal or monoclinic? Only one type of Brevis lattice, which is primitive. Tetragonal, orthorhombic, hexagonal, monoclinic. You can see in this picture. So answer is C. You can see hexagonal triclinic rhombohedral crystal system each contain only one Brevis lattice, which is the primitive in its set. Monoclinic has two primitives and end centers. Tetragonal and orthorhombic has multiple Brevis lattice, including primitive body centered, face centered, and end centered. But hexagonal has only one primitive in itself. Other has monoclinic has two. Okay. See the next question. The coordination number of the atom in body centered cubic is coordination coordination number means, let me explain you first. We have one atom and like that. We have a atoms like that. This is the first nearest and this is second never. larger distance at larger distance. So coordination number for this red atom will be 1, 2, 3, 4. First neighbors will be for this example case. But body centered cubic, you have to find out. Let me draw body centered. One, okay. Let me put one at body and other rest is corner. And this is at body and also this is at body. So which atom is nearest for first red cube? Let me, this is a distance. So this is at in the first cube. If the atom at body, this distance on the x-axis 1 by 2. If nearest also we can join. So this distance between these two atoms will be a. At the corner, what is the distance for air to air? Is more than a by 2. How can you calculate this? Let me tell you, this is a, this is a, this is root 2a. So we have to calculate this distance. This is a, this is root 2a, this is a. So a square, we have to find out this. 2a plus a square, 3a square, 3a. So this is 3a by 2. This is more than half. So nearest atom is adjacent, like that we have 8 cube will be below, up, down. So 1, 2, 3, 4, 5, 6. So how many nearest first is for body center will be 8. 1 minute. Okay, in simple explanation, let me tell you top and bottom like that neighbors. You will find the at. Next question, let me show you. What is the total volume of the particles present in the body centered unit cell? What is the total volume of the particle present in the body centered unit cell? Yes, please find out. In body centered, we have 8 corners, 8 atoms, and one more at the body. So number of particles equal to 2. Now we have to find the volume of these particles. This is the spherical shape like that. And diagonally they are touch each other. This is not like that case. Let me tell you. Will be like that case. This is radius if the r. This is 2r and r. 4r total radius. And this is the diagonal of the cube. Root 3a. Okay. How can you find the volume? You have to find out the r. Please use here 4 by 3 pi r. We can replace r root 3 by 4a cube. This is only for one atom. Or you can put in the in term of the r. Only r is there. Now this is volume is root 3a divided by 16 pi a square. Root 3a replace can be by 4r. This is 4. We can replace by 4. Also put the a value. So don't convert into the simplest is volume of the total volume of this 2 into what is R here? Let me find out. 1 minute. Give me 1 minute. So we have, as I discussed, volume of the one sphere is 4 by 3 pi r cube. The total volume of the all particle we have 2. So, oh, this is 8 by 3. Here is the mistake. So this is the simple. Here is the 8 by 3. Please correct it. So this is simple as we can see. We have two particles. Volume will be, if we let me ask in the other way, please find the volume in term of the lattice parameter. A in term of A. Then you have to convert R. You have to find the relation between A and R, like we have did. Okay, so this is the simple. Clear to you? But in term of A volume, how you can find? Use this relation and put the value in 2 into total volume. Use this relation first and second and find the volume. The question will ask like that. Let's discuss next. We have already seen this question, I think. Yes. Okay. This is already discussed question. Let me check the next. Chromium has BCC structure with the atomic radius 1.35 angstrom. Calculate the lattice parameter for BCC chromium. Yes, please try this question like earlier. You have the pictures. Please, atomic radius. This is the R, which is shown here. 2R and R. You have to find out the A. You can take 5 minutes for this question. Please try first yourself, then we will discuss. I will provide the solution for this. Please try first yourself. Take 5 minutes. So try to solve this question. Any answer? Are you able to do this question? So this is BCC, body centered. You can see relation. This is 4R, and if we apply the PGT theorem, 4R square equal to A square plus A root 2 square. This will be 3A square 4R square. Okay, what is the R here? Let me take roots. 4R equal to root 3A. This is the relation you can use. Earlier we did mistake, I think. Okay, in one question we will revisit on this question, but let's see this calculation. Now you have to calculate A. R is already given. So for A, 4R divided by root 3. Put the value of R in term of angstrom. Please calculate this number. What is the answer? Tell me now. This is something 3.1176 in term of length will be angstrom. Okay, clear to all? This is the body centered, like look like that. One at the center. This is this big one, and other are at the corners. So look like the picture look like that. So this 1, 2, and 3. Let's see here. This is 1, 2. They are in touch, and this is the body diagonal. And let me take this is face centered, face diagonal, and this is 1. So this will be root 2A, and this is A. So this will be root 3A. Okay, and this is equal to 4 time of R. This is R, this is R, and this is 2R. So apply this relation, you can easily get the answer. Clear? In the previous question, yes, one more time question. Here, body centered cubic we have discussed. we have calculate like that 4r equal to 3a by 2, like 3a by 4 or 2, something like that earlier. So which is we did mistake when taking the root. So please let me check again. This is the simple cubic and one at body centered. So which distance is nearest for this? This will be root 3a by 2, which is less than the a by 2. A by 2 is higher for the next cube. So this is at corner is lie on this distance root 3a by 2, which is the coordination of the this body centered. Corner atoms will be the touching for this centered cube and first neighbors. So that's why we have 8 corners 1, 2, 3, 4, 5, 6, 7, 8. That's why coordination number equal to 8. Okay, there is also discussion about the. Now see the FCC structure. Calculate the volume of the FCC unit cell in terms of the atomic radius R. You can see this is A, and equal to 4R. This is 4R A, and this is will be 90. So A square plus A square equal to 4R square. Calculate the volume of the FCC. What will be the volume of the FCC? Face centered cubic. So first you have to find the relation. This is 2A 4R square. If we will take the root, this is root 2A equal to 2R. So R equal to 2 by 2. R will be A by root 2. Use this relation, and if the lattice parameter of the cube is A, the volume of, for this is A cube. Okay, please put the value of A in term of R, like that root 2 R equal to A cube. 2 root 2 R cube in term of R will be the volume. Clear? Okay. Okay, sorry, we did mistake again here also. You are not aware? Please check this is right or not. This should be 4 here. Please check calculation also. This is from here. This is 4r. Now we have to calculate A 4r divided by root 2 and volume simple A cube, length into breadth into height. This is cube. 4 into 4 into 4 r cube divide root 2 into root 2 into root 2. This will be 2, 2 2 is a 4. 2 times, and this is 16 root 2 r cube will be volume. Okay, now it is correct. Please also check the calculation when I first made the mistake. For awareness, you are aware or not? If I did mistake, please let me know. You are seeing now simple calculation. Okay, clear to all now. So let's move for next question. So the atomic packing factor for the FCC crystal is 0.74, or in term of percentage 74%. 74%. How can you calculate atomic packing factor? Volume of the atoms in the unit cells upon total unit unit cell volume. Volume of the atoms in the unit cells. So this is FCC. How many atoms in the FCC per centimeter cubic? 8 are 8 are corners, and also the phase 6 phases, and sharing is half. So this is 4 atoms, and where one atom has the volume. This is the Vs. Atoms, volume of the atoms in the unit cell upon. So this is 4 atoms, and one atom has a volume, and you can also total unit cell volume is a cube, and find the relation between A and R. What is this? So, so find first this and put the value of A in term of R, or R in term of A. In previous question we have also did A cube equal to total volume. 1 minute. Please 1 minute. A equal to, you can use this relation, 2 root 2 r. Use this relation now. 2 root 2 cube. 2 root 2 r cube. R cube goes out and divide by 2, 3, 2 to the power 3, and root 2 also, 2 root 2. Now please calculate this, will be 74%, or in simple term 0.74 will be. Please check this calculation. Yes, this is correct. Okay, I have verified. Are clear to you? If you have a doubt and in any step, please ask. Similarly, you can also calculate for BCC and body centered and simple cubic. Next question, please see. Copper has an atomic radius of 0.128 nanometer in FCC crystal structure and atomic weight of 63.5 gram per mole. Compute the theoretical density. So please use these formulas. Density. How can you calculate? 1 minute. Please see the solution first. This is the new type question for you, I think. This is the formula. N is the where N into A divided by VC and NS. N is a number of atoms associated with the each unit cell. A is the atomic weight. VC is the volume of the unit cell. N is the Avogadro numbers. So we know in FCC 4 atoms. N equal to 4. Atomic weight we have already 63.5 gram per mole. And VC in term of radius you have R given. So we have already calculated VC, we have like that 16 root 2 R, and Na is constant 6.022 10 to power 23. Please put these value in this equation. You will get the answer like that. See, 4 atoms and atomic weight divided by volume and Avogadro number. Answer will be 8.89 gram per centimeter cube. Please verify this answer. This is correct or not? Okay, next question will be on Miller indices. So please see, this is the important concept. Miller indices, plane with intercepts a and b, a, b and c are relative to the lattice parameter is given by plane with intercepts on the axis x, y, z. You can write the equation like that: x upon ax, a, and intercept on the a. Lattice, this is the a, b, c and lattice parameter. Okay, so we design a Miller plane by Miller indice HKL, which is simply reciprocal of the intercept on x, a, b and c, or we can say x and y and z axis. Okay, so these are the steps. First, remove all in indeterminacy, that is the plane should have non-zero intercepts. First, find intercept along the three axes. The crystal system, take the reciprocal of these intercepts in term of ABC, multiply reciprocal by the smallest integer necessary to convert into the set of integer, enclose resulting integer in the parentheses HKL without commas. Without commas. Okay, let's see the example. We have the A, B, and C, X, Y, Z, like that direction. So first you have to find out the step. First find the intercept along the axis A and B, C. So on the A is 2, then air is a 3, and one air is a 1. Take the reciprocal of the intercepts. We taking the intercepts, second step, convert into the smallest integer, means multiply by like 6 here, you will get here, and enclose in parentheses you will get 326. Okay, so and this is question next. A set of identical crystallographic planes in the crystal system is denoted by set of identical crystallographic planes. This is HKL, simple plane first, but set of identical crystallographic planes will be curly brackets. Please see, for the one plane, this is HKL, simple. If HKL curly bracket are used with the set of identical planes, and square brackets single direction are uses, and this type of parenthesis set of directions. Please remember these notations for the Miller indices. Okay, let's move forward for the next question. Miller indices are used to represent atomic mass, crystal shape, length in the crystals, density of the material. Please answer of this question. Please take 1 minute, but let me know the answer. Okay. As we discussed, your answer is correct. C. So this is used for the planes in the crystals. HKLR represent the planes in the crystals. Okay. See the next question. If the intercept of a plane on the x, y, and z axis are 3n, 3b, and 2c, respectively, ABC are lattice parameter, Miller indices of the planes are. Intercept are givens. So first step, find the intercepts. Then second, take the reciprocals of the intercepts. You can use also ABC. So ABC all cancel out. And third steps, multiply by the integer, convert into the smallest integers. So you can use multiply by 6. Don't use the commas like I used. Okay. Clear? Easy. So now the next question is the angle between 102 and 111 direction in the cubic lattice. This is this for the single plane. Direction for the single plane. You can use cos theta equal to h1 h2. Okay, please use this formula. Now find the theta. You can, okay, A. Other, please answer. This is the simple question now. If you know the formula, so let me show you the answer. Okay, when I put the value HKL, you can use this is the formula. Sorry. we have given these planes. Use HKL or U1, U2, whatever you want, note the notation. After putting in this cos theta, you will get the answer 39.2 degree. Okay, so next question also on the Miller indices. What are the Miller indices of the plane that intercept the x-axis at A, y-axis at B, and parallel to the z-axis? Yes, please answer for this. Find the first step, find the intercept. A, you have B, and z-axis parallel to the z-axis means infinite C. Second step, take the reciprocals without A and B, C. Okay, which is 1, 1, and 0. Also, this is the smallest position already. Use the brackets. So, this is the correct answer. Which one is the answer now? Yes, please. See which option is correct. A and D are similar. So, I have to change. Let me put like that. Clear? Next question. What are the Miller indices used to describe in crystallography? The hardness of the minerals, the specific gravity of the minerals, the crystal structure and plane in the crystal lattice, the color of the minerals. So earlier we have already discussed this question, planes in the crystal. So also this is crystal structure and plane in the crystals. Next, what are what is the Miller indices represent of a plane that is parallel to the three axes in the cubic crystal system? Yes, please. See, here is the twist. Please see. Okay, let me show you. Okay, your answer is C, but answer C is not correct because if 0, 0, 0, this is not a plane, any plane, and there is no physical meaning of 0, 0. So let's see, read the no valid Miller indices for plane that is parallel to the all three axes. because such plane never intersect the crystal lattice and doesn't exist within the unit cell. Therefore, the representation is undefined or invalid in the crystallographic. This is undefined or invalid. So this undefined, you can also select the D option. This is undefined. Okay, 0, 0 has no meaning in the crystallographic because this is the outside the unit cell. Next question. In a tetragonal crystal system, what are the Miller indices of the plane parallel to the y-axis? Crystal tetragonal crystal system is given and parallel to the y-axis. Parallel to the y-axis. On the y-axis, value of x and y, x will be 0, y like that. The coordinate of the any point, take the reciprocal. Can we write like that? Yes or no? Please check yourself first. For the tetragonal crystal system, so answer is A. So parallel to the y-axis, infinite on the y-axis, cut on the infinite. 1 upon infinite will be 0. So find the which option is 0 first. A and C, and take the similar mirror indices on x and y. Let's say 1, 1. For the any crystal system, let's cut first the A and A like that. This is the intercept, and 1 by 1 0 and 1 by A, let's say A. This is 1 infinite, sorry, 1 upon infinite 0 and 1. Okay, and see, any 7 crystal system, cubic, tetragonal, orthorhombic, etc., independent of the specific crystal system, Miller indices. Okay. Next question. How are Miller indices represent the crystal plane that intercept x, y, and z axis at 1 by 2, 1 by 3, 1 by 4. This is the intercept on the XYZ axis. Now please find the HKL. Simple, take the reciprocal 2, 3, 4. Okay. Next question. The symmetry represent operation represent in 2D crystal lattice is R. In 2D, only reflection and rotation are present. Translation also rotation and reflection. In 3D, translation, rotation, and inversion. In 1D, translation and reflection. Okay. Next, the defining symmetry of the cubic crystal system is. Please see the option. Answer is B. 4 3-fold symmetry. For the cubic, you can see 4 3-fold cubic symmetry for the cubic crystal system. Next question. A face-centered cubic FCC unit cell is not reduced as a two body-centered tetragonal unit cell because the FCC unit cell is bigger than the body-centered tetragonal BCT unit cell. The FCC unit cell contain more lattice points than the BCT unit cell. Symmetry of the BCT unit cell is higher than the FCC unit cell. Symmetry of the FCC unit cell is higher than the BCT unit cell. So answer is symmetry of the FCC unit cell is higher than the BCC. And you can see also the from lecture. Sir is explain why can FCC not be the represent as the BCT unit. Symmetry FCC is higher than the symmetry of centered body centered. Next question. Following reason explain the absence of the end center cubic lattice among the various brevis lattice. So this question I think we have already discussed. So it's violated the symmetry requirement of the cubic and it can be represented by the simple tetragonal system. Okay, next question. Which of the following rotational symmetries are not present in the periodic point lattice? 3, 4, 5, 9. Which one? So 5 and 9 cannot be fulfill the full space. So that's why these are the absent periodic point lattices symmetry in. There are gaps. And similarly for 9. Next question. How many of the 14 Brevis lattice contain two lattice points? Two lattice points. So these are the when you calculate from there two lattice points which has like that 5. We will find the 5. A set of identical crystal plane. This question is repeated. Oh, okay. Let me ask like that for direction. Set of direction identical crystallographic planes in the crystal system is denoted by for the direction. Set of identical crystal plane for the direction. Direction will be last one D option. But for the crystallographic crystal system is curly brackets. If the intercept of the planes on the XYZ axis 2A, 2B, 3C, this is already discussed question, I think, or not, then not, please see 1 upon 2A, 3B, 3C, take the inverse and convert into the smallest 322 will be the answer. Angle we have already calculated. This is repeated question, sorry. Next question is new. The interplanar spacing in angstrom between the triple one planes of the cubic lattice with the lattice parameter 3.5 is, you have to find D. So answer is this. You can use this relation HKL is equal to 1 upon h square k square L square with the ABC lattice parameters. Then put the value of, you have HKL and you have A. Then put the value A and HKL, you will get the value of D, interplanar distance between the planes. Okay. Next, draw the 110 and 111 planes. Let's see. You have X, Y, Z. Please see this. X on the A, A, A. This is cutting here, cutting here, cutting here. Please join these. So this is the 111 Similarly, you can draw. So please see 1 on the x-axis 1, y-axis also 1, z on 0 means infinite. Cutting on the infinite. Next question for the plane 111 HKL of the FCC having a lattice parameter A, planar atomic distance density is given by lattice parameter A, atomic density is given by. So C, 111 plane on FCC. We know in FCC 111 plane contain two atoms, which is 1/6 for the three atoms, 3 sharing, and 1/2 of the 3. So this is ultimately give 2 1 by 6 from the 6 planes. Sorry, half of half from the planes. 1/6 contribution is from other. This is 3, and we know the equilibrium triangle area. 0.86886 a square. A area will be equilateral triangle area on the XYZ axis. And now you can density 2 atoms divided by the area. You will find the answer, which is A. Next question. A compound of is formed by atom of element A occupying, occupying the corner of the unit cell, and atom element B present at the center of the unit cell. Reduce the formula for the compound. So question is like that. A is on corner, B is centered. So contribution of A 1 upon 8, and at corner will be 1, and B equal to total 1. So what is this? AB. Next question. If a crystal lattice has 6 close packed spheres, what are the number of the tetrahedral voids in the lattice? So for the n closed sphere tetrahedraloids are 2n. So n equal to here is 6. So tetrahedraloids will be 6 to the 12. And octahedroids will be n. Okay, next question. Which of the following agreements of the particles does a simple cubic lattice follow? Simple lattice. Simple cubic. Only A-type atoms and only at the corners. 1 by 8 into 8 will be 1. So, and arrangement will be a triple A layer. 3D packing for. Next question. Which of the following crystal system has all angle equal but not 90 but different as length? Is equal 90, alpha, beta, these are not equal. Which one? Yes, please. So this is simple orthorhombic. So this is all about today. Thanks to all of you. We will discuss assignment third on next Monday. Okay. Okay, then thanks. If you have doubt, you can ask. Otherwise, we will end the session. If don't have query, let me close the session. We will be on next Monday.